Hello?
Hello.
Hello? Hey.
Hello.
Yes.
Hello? Yeah. Attention up here, right? Okay. So I know those earbuds are not in your ears right now.
There's only one.
Oh. Okay, I'm sorry. I know that earbud's not in your ear right now.
Okay.
Listen up, community college. Yeah. Anyway, manufacturer needs to produce a cylindrical container with capacity of 1,000 centimeters cubed. Top and bottom of the container made of material that cost 5 cents per square centimeter. Okay, while the size of the container is made of material costing 3 cents per square centimeter, find the dimensions that will minimize the company's cost of producing the container. First,
Read it again.
read it twice. We go through, so we read it all the way through. Now, let's identify the things I need to address. I have a volume of this. It is a
Cylindrical.
container. Top and bottom of the container cost 5 cents, so top and bottom. Sides of the container costing, okay, find the dimensions that will minimize the company. So I'm trying to minimize cost of producing this one. Okay. So first, since we're talking about a cylindrical container, what formula do I need to talk about? I'm trying to contain, right?
Yeah.
So I would be referring to the what?
Area.
Area, not the volume.
Sure.
Okay? But the volume has to equal 1,000, right? The container is an area. So I'm maximizing the cost of the container, and it's supposed to be equal to this volume, right? So let's start off with, we have two different things that we're doing, because it's going to be equal to the volume, and it's also the container's area. So let's talk about area first. Area would equal, now the top and bottom together are what shape?
Circles.
Circles, right? So I know since it's a circle, I'm going to have the area of a circle. And I have a top and bottom, so it's going to be 2 pi r squared, right? Okay? That's the top and bottom. But now, I'm gonna sketch this right here so you guys could actually see this part. So, now we're talking about the sides of the container. I know this is the height, right? This is the radius. But now, going around, so if I were to lay this out, it would look like this.
Wow.
Hopefully not that bad. It'll look like that there, right? So I have the top and bottom, and I have, so let's transfer some of this. So that's the height, right? This is the radius. So right here, right here would be what?
That'd be your circumference.
That's the circumference. Very good. That's the circumference. Because it's wrapping around the edge of the circle, isn't it?
Yeah.
So that's going to be my circumference. So my formula for circumference is what?
Don't remember.
Isn't it 3 something?
No.
Isn't it? 2 pi r.
Yep. 2 pi r.
Oh.
Yeah,
If you say
okay.
anything, I was like, this is wrong.
So it's going to be 2 pi r. That's what this is right here, right? So this is 2 pi r. And to find the area of the whole piece, it'd be times what?
Height.
Height. There we go. So now I have the formula. I just made the formula for the area of the cylinder to include the top and bottom. Make sense? Did I lose anyone yet? Not yet. Good. No? Am I erasing too soon? Okay. No, it's fine. I'll redraw it. I just need. I wanted to redraw it on the next page anyway. So we have the radius here, 2 pi r, and this is my h. Are we okay now? Okay, good. All right, so we have that one, and we also have the volume, right? The volume of the container, so volume would be, what's the volume of a cylinder?
By oh god, cool.
Hello?
Hello.
Volume of a cylinder!
By r squared h.
Yes.
Thank you.
So it's going to be pi r squared h.
You need to watch this video.
Okay, so I have this value, and if you think about it, what am I trying to maximize? I'm trying to maximize the cost, right?
Minimize.
Minimize the cost, yes. I'm sorry. So I'm minimizing the cost of producing this, right? So I'm going to make another equation out of this. So it's going to be the cost, right?
Yeah.
So cost would equal, now this is the top and bottom, right? What's the cost of the top and bottom?
0.5.
There we go.
0.05, my bad.
Okay, so it's going to be 0.05 times pi r squared plus. Now, what's the cost of the side?
0.03.
Yep. So I get times my 2 pi r h. So I've incorporated the cost into the formula here, right? So I also have to somehow incorporate the 1,000 centimeters cubed, and I have to try to maximize.
Minimize.
I'm sorry, minimize. So I'm trying to get the best container, maximize container, minimizing cost.
I mean, do you have to maximize it even though it already gives you the volume?
It gives me the volume, but you'll see why I'm actually using that one. Okay, so now that I have this, you guys all have this written down? Because I'm going to the next page. So, given that I have 1,000 is equal to pi r squared h. Can I try to solve for h here? Because doesn't my other equation have r's and h's together? Yeah, it does. It has r's and h's together. So it has, the cost will be everything. I have r's here, I have an r and an h over here. But I don't like having that many variables. I want to try and get rid of variables. So when I'm doing this, I only have one variable. And that's what I'm going to do with the volume over here. Since I know what the volume is, I could say that H is equal to 1,000 divided by pi r squared. Agreed? Yeah? Okay, good. So I'm going to plug that into my cost formula. So C is equal to, that's going to be, let me see. I could actually do this multiplication right here. So the 2 times this to try and get rid of the 0.05. So I just wanted to make sure. So this right here, so 5 cents times 2 gives you 10 cents, right? So, and the other one's going to be 6 cents, okay? So it's going to be 0.1 pi r squared, right? Plus 0.06 and so pi r, but instead of h, what am I putting? This thing right here, this whole thing. So 1,000 over pi r squared. Make sure I have everything there. Yeah. So minimize cost. Okay. So I have this equation now set up for cost, right? Because I inserted the amount for each of these parts. So now, if I'm going to minimize or maximize this right here, I have to take the derivative. We're going to do the derivative, right? So I'm going to have, let's see, C prime is equal to 0.2, right? Pi r, and this is going to be, so if I rewrite this, wouldn't this be, cancel out the pi's, right? Cancel out one of my r's, and is this the same as saying r to the negative 1? Yes. Because to take the derivative, I want to have r in the numerator, so I could just take the derivative, so it's actually, bring it down and then subtract 1. Okay, so this is going to give me, let me see, what is 0.06 times 1,000? 60, right? It's going to be 60, so I have that part right here. So this is 60. And now let's take the derivative. What would this right here be? What would this do? It'd make it a negative 60 over r squared. Very good. Because I'm going to subtract 1. So negative 1 minus 1 gives me that negative 2. And then that's going to make that one become with 2 down here. Okay? Did I lose anyone?
Wait, why is it r squared? Because I thought you got rid of the r.
Okay, so I'm subtracting 1, right? Negative 1 minus 1 gives me negative 2, right? And so it's going to be r to the negative 2. And then if I bring it back down across the divisor right here, so it's going to be 1 over r to the positive 2. When you bring the variable up and down,
No, I know that. But like, I thought, did you bring like the regular r up?
yes, right here. Because there was 1 right here and 2 down here. There was a r here and an r squared right here. So I cancel out the r squared. So there's still just an r here. Because I only cancel out one of them, right? So this was, so here, let me rewrite it so we see this. So we said 60 over r, right? That's what was left after I canceled everything. And so I'm rewriting it now. So if I rewrite that, that's 60 r to the negative 1. That's what it was right here. That's why I wrote that. Okay? All right. Okay. So now we got this right here. So now, since we're minimizing cost, so I need to set this equal to
3.
what?
3.
Yeah, 0. Set it equal to 0, right? So I need common denominator also. So this is going to be over 1, right? Say yes. So that's over 1. And to have a common denominator, I have to multiply this one here by top and bottom by r squared. So this is going to be r squared. So I'm still with c prime is equal to, so this would be 0.2 pi r to the third minus 60 over r squared, right? Yes?
Yes.
Okay, so set it equals 0 equals, okay? Now what's going to happen to my denominator here? When I set anything equal to 0 like this, I could actually get rid of the denominator, right?
Mhm.
Multiply both sides by r squared. 0 times r squared is
0.
0, so that doesn't change. But the r squared on the bottom over here goes away now, right? So I'm left with 0.2 pi r cubed equals 60. Oh, not, yeah, it's minus, not equals. Sorry.
Have you had your coffee today?
Yes, and it was quite weak this morning. So, I need to go complain to my barista. I mean, wife. Okay, so add 60 to both sides. So 60 equals 0.2 pi r cubed. So that's going to give me, divide both sides by whatever this is. So 0.2, what's that, 300?
Yeah.
300 over pi equals r cubed. And then we have to take the cube root. So r is equal to the cube root of 300 over pi. So I'm going to get decimals on this. So how many decimal places do I always have to use?
3.
3. I always have to use 3 because that's what the AP test says. Calculator. Not phone, I said calculator.
Calculator.
No, go get a calculator.
I just got to put it back in like 5 minutes.
Oh my god. Huh? How did I get 300? 60 divided by 0.2.
Oh.
Yeah, watch this. Watch
Yeah,
this.
yeah. Sorry. That's her.
And then divide. So we could do the whole thing now, right? So control here and control divide.
But that's not. It's not.
Oh yeah, that's square root. I mean cube root. Did you already have that cube root on there? Okay, so there's square root of can you? There we go. Right. So 4.57. So R is about 4.570.
571, wouldn't it be?
I don't know, what's the next number?
7.
Okay, 1. What are my units?
Something. It's something.
centimeters. So to maximize this, my R would be 4.51 centimeters. Now, what do I need to do to figure out my height? Plug that into right here, right?
Yeah.
So we need to figure out the height too. Turn up the brightness.
No, I can't see the keys. It's too dark. I have to do glasses.
What did we come up with?
15.235 or 234.
Yeah, 234.
So, we have a volume of 1,000 cubic centimeters, a height of 15.234, and a radius of 4.571 centimeters. Not too bad, right? What was the hardest part of this?
Figuring out the variables. That's
Yeah,
easy.
figuring out the variables, setting it up, right? Looking to see what it is I was talking about. All right, like, subscribe.